So hi everybody and welcome back. This is a C++ tutorial series for absolute beginners. This is video 194 and in this video we are talking about Const Cast. And what is Const Cast? It says here converts between types with different const volatile qualification, which means we have here a syntax and you can see it's similar to our static cast syntax. Here is our expression again, which means our original type. And this here is our new type, which we want. And important in this version with the const cast is one of this expression should have const in it, this side or this side. And what you are trying to do is then, if the original expression has a const, you get rid of the const with the new type. And that's the reason why we are using const cast. And this is a special cast because const is normally a very strong key, indicator. You want not change something. And if you are changing this const, then you are breaking normally C++ rules, but in some cases this is necessarily, and that's why they have here this const cast. But very important, as a beginner, we will try to avoid const cast. It's more for advanced people and for professionals who really know how to use this and that it will not cause problems. Okay. With that said, you can read here a little bit the explanations again. Important is we are jumping directly into the examples, and we start with this example here to see how this const cast works. So let's copy this one, paste this, and we'll see what it does. So first of all, we declare here a normal variable and initialize it with the value 3. In a second line, till this point here, you can see it's a just normal const variable reference, right? We already talked about it. This is const, which means you can't change later the value. It is a integer reference, which means we are referring to this one here. And because it's a reference, we have to initialize it directly with a L value. And we are doing this one. Important is now, after this point, we can't LCI, we can't change here any value, right? Because we made it const. If there is no const, I can change it. All right, so far so nice. And in the next line, what they are doing is, because whatever reason there is, I don't know what, they want to get rid of this const. And to get rid of this const, we use the const cast. Here we have our original value where I said the original value must have anything with const or without const. Here we have something with const, and the new type which we want has something without const, but you can see we are just getting rid of the const. The other one stays here when we use a const type. And after this conversion here, they can initialize it, and you can see they changed the value, which was not possible before, to from 3 to 4, and when we run it comes out. And important is this action, what you see right now, is only one time action, because this kind of stuff advanced people do sometimes if it's necessary. And why is this one time action here? Because this LCE here is again not changeable. And what they did here is just call this temporarily, change this temporarily here, and that's it. So they have not saved this const cast in a variable so that they can change it all time. And you should not change something what is declared as const normally at all. But like I said, advanced people and professionals, they know it. We as a starter, we will never change it. And the reason for that, why we want to change it, you will see now here in our next example, which is this one. And let me see what we have here. Oops, I have to copy one more thing here. This struct here. Struct is just a type. And you can see we are creating here a struct similar like a class. Oops, sorry. Struct and class are similar. The only difference is here this access specifier and a little bit access specifier for inheritance and something like that. But they are similar. And you can see they are creating here a member variable, integer. They create a constructor, which is initializing the I with a 3. And they creating here a member function, which is const. Very important. Const as a function means you are not allowed to change anything in the body, but you can see this line is trying to change something. They are trying to assign this argument v here later to I, right? This is here just a pointer assignment, which we know already. And here they can do it. Here on the other line, they can't do it. And we will talk about this in a moment more. Let's start here. First of all, what they are doing. First, they create just an object of this struct. That's okay, normal. And let's read what they are writing here. Also, if this was const type t, then okay, this we can I will explain this in a moment, but let's go on. So let's see. We created a variable t. Then we use the t and we use the access specifier and called the const function. Just normal. And we give this function call here value. Interesting is here this here. What do you see here? We can access this. Okay, that's all right. And let's go on a little bit. And why we can access this is very important. They are public, right? Just in case, because normally class are private. So, and if you want to be sure, just write here public. Public. Make this one to be sure that this one is accessible, that you understand it. But struct by default has public specifier. All right, I hope that's already known. So let's go on. We have now here this t. We can access this const function here, and this is const. Normally, when you hover your mouse over it, you read this const. You should understand this tooltip. But interesting is you pass in a value and they change it. It's bad style normally. But let's go to this line here fast. It says here, this is an error. Why is this line an error? First of all, let's try to understand what they do. First of all, they are using the dis pointer. We talked about the dis pointer all time. When you create a struct or the class, the compiler is creating a special pointer which is called this. And if you want to access this pointer explicitly, which means intentionally, then you are using this version. But normally you can write it this version too. This is the same like this one. We talked about this one. So the problem is here why this one is an error. And the reason is very simple. That this here, when I hover my mouse over it, you can see the compiler is treating this hidden dis pointer in a function which is declared const as well as a const dis pointer. You can see the tooltip. I hope you can see it. It says here const type as a pointer const type, right? And this here is not allowed because a const pointer is not allowed to assign a value. That's why this is not allowed. All right, we understood this now. And now we are breaking the rule like all time with const. We say, okay, we know that this pointer here, this hidden dis pointer is our expression. We know that the type is, when I hover my mouse over it, you can see the type is const type pointer. That's what I showed you here. It's the same thing. And we want to go rid of this const, because when we go rid of this const, this becomes a normal dis, which means you are allowed to assign something. And you can see that's the reason why this one here is allowed. And that's the reason why we can do this. And like all time, it is bad for beginners. Don't do this. What you would do normally as a beginner is, instead doing something like that, just create here a function, another function without const, right? If you really want to change it, then just create a function without a const and kick this out. And then you don't need this one here. And then you can just use this one and there is no problem, right? If you really need this, because this is now allowed. This is a normal function. And this one, you can see, let's call this TF here. And here is overload because const and non-const are yes, specified. You can call this and then change which we want. Yes, we talked about this, right? So in general, as a beginner, try to avoid using something like that. Just if you want really change values, make it non-const function. All right, let's continue here a little bit with this example. And I said this example is very, very, very bad. Why is this very bad? This is allowed so far. But look what I do now when we read this line here. When we change this one to const, and it says here, this type, which variable I created is now const. It says here, if this is a const, it has this TF here, the next line here, has an undefined behavior, which means it can not work, compiler error, crash. And let's test here what happens. Let's get rid of this one and let's see if there is a crash, a compiler error or something like that, because I violated now some rules. And look what happens on my machine with my settings. There is no crash, there is no compiler error, there is no compiler hints or something like that, and the value is right. And that is the worst case for a programmer. Why is this the worst case? Because if this behavior is identified as an undefined behavior at this point, this can be right, this can be no compiler error, this can be the right value all time. But undefined behavior means it can be also in future that after you release your project, that anytime this little function here call will change the value unexpectedly, and then your program might crash and you have a bug. And why is this one of the worst cases in programming? Because, like I said, at this point when we program it, we don't see an error, right? It looks perfect. There is no error, you don't see it, you say, yes, I expected this value, the conversion is working. And the only way to figure this out if there is a crash is then you have the knowledge to see something like that. That's very hard. Or you have very good debug tools. That's probably the easier way, because to find the place where anyone coded this in a over 10,000 line code, it's very hard to find. But with debug tools, you find these places and then you figure this out. So this is one of these crap cases in programming, which you should definitely avoid. And that's why we as a starter, we will not make this Const Cast in general. The whole time when you see a Const Cast, be very careful and research before you make this. You can see this is an example. Yes, if you have no knowledge about this one, you would just use it. It would work till one time it not work, and then you have a big problem. And the next example actually is similar to this one. This one is similar to this one. So we have here another example. Here it works. Let's get rid of, let's keep this one because it's similar. So what we are doing here is, again, we are creating a variable, but this variable is const, right? You can see this variable is const. And now I try to again, I use my Const Cast. I change when I use Const Cast, I change all time the type. So my original type, which is this one, when I get it from here, we can see this is the operator AND operator. And G means I get the address of G, which is this one here. And this one, this expression here becomes when I point over it, you can see it says here a const in G. That's not really true. This one becomes here, if this is evaluated, this becomes a const int pointer, right? So this one becomes a const int pointer, and then you can convert this to an int pointer. And why I say it's not true, this one is true what it shows, but this one shows just the original address, which means it is just showing this one. It is not showing us the type which is here used. It's not expressing that. And if you don't believe me, then we can use a debug. And I debug here. I start. And the debug here, you can see we have here this ng here, right? And you can see it's a const in pointer at this point. That's very important. And you can see this const in pointer will be converted to an in pointer. We get again away this const here because we are using this const cast, and that's it. So, and we have here a problem. What is the problem here? Again, the next line is the problem here that was commented out. It says here again something like undefined behavior. This one works so far, but if you try to difference now this value, which you would perhaps try because this is just a pointer now, and pointer differencing means you're trying to assign this a value, and if I try to assign a value to it, and if I try to print this out, and here I try to print this out like they say it, AG, and yes, let's print this out. And whoa, it works perfect. Again, no compiler error, no warning. You say, and you as a beginner say, yes, I made here a const conversion. I saved it here. I have a variable, a pointer. I can do this. That looks really normal. And that's, again, very, very dangerous. Undefined behavior for a beginner. This works now, perhaps, but it must be not work in the future. And this causes, again, big problems. Again, how to find this error again. It looks so normal. You need, again, knowledge and, of course, special debug tools to understand this, or yeah, something like that. And I think that's enough for our const in general. So the thumb rule is, as a starter, try to avoid this. At once, and professionals, they know the places where they have to use it, because there are some cases where they have to use it. This depends on, I don't know if they are using not C++. I think they are something with C. They are merging this, and then they are using libraries from C. Then they have to use sometimes this kind of stuff. But in general, try to avoid const if it's possible. And if you are using it, research this very well, because if you have something like this examples here, which looks very, very natural, and they work, they can cause you a big crash, big problems with your program. So that's what I have to say in this video. And with that said, I stop here. And if you have any questions, any suggestions, like all time, write it in the comments. See you in the next video. Bye, good luck, and like all time, never give up.